Hello all again. This will be chapter 6, part of the skeletal system. Mostly bone tissue is what we are looking at here. Okay? So, functions of the skeletal system. Quite a few. Most notably, we are providing support for the body. We have attachments for different body organs such as muscles. We have to have muscles attached to these bones to help us move. Okay, we are also providing protection for internal organs. So think of the rib cage, the pelvis, everything housed within, protected with a nice, strong, sturdy structure. We are assisting the body in movement, again, attachment of muscles. We're storing salts such as calcium and phosphorus for later use if needed. We are participating in blood cell production, so we're going to see red and white blood cells alike produced in bone. And we are storing triglycerides in the adipose cells of the yellow marrow, so a little bit of energy storage is happening here as well. Okay. All right. So, structure of a bone. Mostly long bones. Not all are consistent. Not all have these parts. But with long bones, which is what we think of most of the time, so the femur, the humerus, our forearms, our lower legs, this is going to be talking about those types of long bones. Okay. The main portion of the bone, the diaphysis, is going to be the shaft. So this is the longest portion of the bone. At each end we have epiphysis. These are going to be the ends of the bones that are going to create joints. So at the knee we have two epiphyses that are going to be located either on the femur or the tibia. And then in between the diaphysis and the epiphysis are going to be a metaphysis. This is the space between. And then the articular cartilage, again, mostly hyaline cartilage, like we talked about before, creating a nice smooth surface for joint movement. Wrapping the bone at the diaphysis is going to be periosteum. So this is connective tissue that surrounds that diaphysis. The medullary cavity, this is the hollow space within the diaphysis. And then within that medullary cavity, we have another wrapping, the endosteum. This is going to be the thin membrane lining that cavity. Okay, most notably, I do want you to know diaphysis and epiphysis for sure, as well as periosteum. Okay, here's a look at those parts. So again, diaphysis is going to be the long, slender portion of the bone. The metaphysis is the space between the diaphysis and the end of the bone, which is going to be the epiphysis. Now, you can see this small little line right here. This is the epiphyseal line, or growth plate. So this is where the bones are actually growing. Okay, internally we see that medullary cavity. We've got blood supply, nerve supply moving through there, the endosteum, and then on the outer surface of the diaphysis we have the periosteum. Okay, making up the bone we have four types of cells. One is going to be osteoprogenitor cells. These are the bone stem cells. These are differentiating into the other types. Okay, we have osteoblasts. These are bone building cells. So these are secreting the matrix that will create the bone itself. Mature bone cells will be the osteocytes. Okay, on the other hand, we have osteoclasts. These are for bone remodeling. Okay, we're causing a release of calcium. So whether it is for bone healing after a fracture and creating more of a surface that is more continuous with the healthy bone, or if it is for creating more calcium for the body to use by releasing that calcium from the bone. These osteoclasts are breaking down that bone matrix. Okay, here's a nice little look at those. Osteoprogenitor cell kind of looks like a cell that doesn't know what it wants to be. Then we turn into an osteoblast, which eventually will become an osteocyte that helps maintain the bone tissue. Okay, on the other hand, coming from white blood cell lineage, we have the osteoclasts. Okay, so here we will see the difference between compact and spongy bone. Again, compact, a lot of calcium and phosphorus. This is going to help with support and protection. Spongy bone, more of an airy type of structure, a lot more porous and lightweight. We're having blood cell production take place here. So we see compact bone, which is all through here, and here is that osteon we talked about. This is going to be the main difference between compact and spongy bone. Compact is very organized, very densely packed into these osteon structures. The spongy bone, on the other hand, is going to be a lot more airy. So a lot more space, again, kind of like a cavern, almost looks like coral on a reef. Okay, we briefly spoke about all the different types of structures found within the bone, the canaliculi, the lacuna, and these are just the different types of structures. The canaliculi are going to be the pathways for the osteocytes to be able to connect to each other to maintain support. The lacuna is going to be the space where the osteocyte is laying. Okay, the lamellae are those concentric rings of calcium and phosphorus deposits, the matrix secreted from the osteoblasts. Okay, blood and nerve supply to the bone. I'm not overly concerned about this. I just do want you to know that there is a large amount of blood supply to the bone. Seeing as how we do need to create blood cells here, we have to have a lot of nutrients to do that, so therefore we need a large amount of blood supply. Nerve supply as well for maintaining health and life of the bone. Okay, speaking of formations, bone formation, also known as ossification or osteogenesis. Osteo is bone, genesis is the beginning, so the beginning of bone. Okay, we've got 4 different conditions as to why bones will form. So the first will be during development in the womb. Obviously, we need to create bones to create a way to support our body. From there, as we grow into adulthood, our bones will continue to form until we have reached our maximum capacity for bone growth. That usually happens at about age 25. Okay? And then when bones remodel and bones heal from a fracture. So ossification, we have 2 different types or 2 different forms of ossification. We have intramembranous and enchondral. So intramembranous ossification, this is going to be flat bones for the most part. So the connective tissue membrane, intramembranous, the membrane is being replaced by bone. So think of the fontanelles on the skull of a baby, those soft spots as everybody calls them. Those are membranes that will eventually be replaced by bone. Bone formation in the form of endochondral ossification. This is what we think of with bone growth, growth plates, and everything like that. This is going to be where cartilage is being replaced by bone. Okay, so at the epiphyseal plate or the growth plate, this is actually cartilage. that will eventually become bone. Okay, so as the bone forms, how we create those osteons is going to be a blood vessel laying on the surface of the bone. Then we will eventually start to wrap around that blood vessel because we want to keep it intact to maintain life. Then eventually we completely enclose and we just continue on. If anybody has ever seen barbed wire on a tree, you'll notice that the tree starts to form around that barbed wire. It's kind of a similar situation as we see here on this slide. Okay, fracture repair. So a fracture is a break in the bone. We have 3 phases to the healing process, including 4 steps. So phases, we have reactive, reparative, and then the bone remodeling. Okay, the reactive phase is going to consist of inflammation. So we have a large amount of blood flow to that area. This is going to help with keeping infection at bay. It's going to help with bringing in fibroblasts, osteoblasts to the area to help heal this fracture. Reparative phase, wow, I can't speak. Formation of a fibrocartilaginous callus. And then this will become a bony callus. So those fibroblasts will lay down fibrocartilage, and that will help kind of glue the bone together and create the area as to which bone will start to replace cartilage. So endochondral ossification is taking place again. So from this, once we start to create that bony callus, that is the second step in the reparative phase, we finally meet our bone remodeling. So osteoclasts start to do their thing, and we help to recreate a normal surface of the bone. Now, there's still always going to be a little bit left over compared to what was normally there, but this is kind of like scar tissue for the bone. Okay, so some clinical notes, some different types of fractures. An open or compound, which means the bone has broke through the skin. Comminuted, this is going to be where there are fragments of the bone. Green stick, think of taking a small stick that is still green from the tree. It's not completely dead and dried out. When you go to bend it, it might only break halfway through. We see this a lot in children. As their bones are still growing, they're a little extra pliable compared to us as adults, and it allows for this green stick fracture. Okay, impact. So we are pushing part of the bone into another. The pop fracture. So distal end of the fibula has been fractured here. Colles fracture, the distal end of the radius is going to be fractured here. A little story of a way to remember this is if you're walking your dog and the leash is around your wrist and your dog happens to be a collie and the dog takes off without you realizing it, pulls your hand forward and ends up fracturing the end of the wrist there. Alright, so here are some links for you, and if you have any questions, please email or ask me in class.